The Ugi reaction is a multi-component reaction involving a carbonyl, an amine, an isocyanide, and a carboxylic acid to form a bis-amide. In 1959, Ivor Carl Ugi first reported this reaction. The Ugi reaction is exothermic and complete within minutes of adding the isocyanide. The highest yields are observed when the concentration of reactants are high, usually 2 molar. Polar aprotic solvent works the best, however methanol and ethanol have also been used effectively. This uncatalyzed reaction has an inherent high atom economy since only a molecule of water is lost and the chemical yield is generally high. Due to the reaction products being potential protein mimetics, there have been many attempts to develop an enantioselective Ugi reaction, the first successful report of which was in 2018. The Ugi reaction products can demonstrate a wide variety of substitution patterns and constitute peptidomimetics that have potential pharmaceutical applications. This reaction is thus very important for generating compound libraries for screening purposes. In order to form this bis-amide, we need Ugi reaction. It's a 4-component reaction. First is your carbonyl, second is your primary amine or ammonia, third is your carboxylic acid, and your fourth component is isonitrile. So here we have a carbonyl. So this oxygen has lone pair, so it's going to abstract that hydrogen from this carboxylic acid, making that a carboxylate. Now once it's protonated, your carbonyl, you have a good electrophilic site, which is this carbon right here. So your primary amine, which is a nucleophile, is going to come in, attack that carbon, push that electron density towards the hydroxyl group. Now you generated a protonated amine. So proton transfer is going to happen, where this hydroxyl is now going to become a good leaving group, which is water. So this lone pair on this nitrogen is going to come down and expel that water out, forming this iminium ion. Now your isonitrile is going to come in, which is a good nucleophile, and our electrophilic site is this carbon, is going to attack there and it's going to push the electron density towards that nitrogen. You're going to generate a nitrilium ion. After that, we freed carboxylate in the first step. So that's going to come in, that's going to attack this electrophilic site. It's going to break that pi bond and push the electron density towards that nitrogen. Now we're going to generate isoamide because we just break one pi bond, right? And we had a nitrilium ion. So this is going to be the important step. So we're going to do mum rearrangement where 1,3 oxygen nitrogen acyl transfer is going to happen. So here we have this nitrogen. It has lone pair. It's going to attack right here, grab that acyl part, and this carbon-oxygen bond is going to break, right? So basically, this oxygen is now going to form that pi bond, push the electron density towards that nitrogen, making it negatively charged. And this is going to be protonated amide. So now we generate this, right? On the left side, you have this protonated amine. On the right side, you have a negatively charged amine. So we're going to have a proton transfer, and that's how we're going to generate bis-amide. So that's all for Ugi reaction.